Hi everyone, this is an introductory part of the first lesson in the expressions course from Motion Design School. Today we will learn the basics of expressions and how to work with them, as well as get acquainted with many basic concepts that we will need throughout the course. Let's begin. Why do we need expressions anyway? We need them for all the cool stuff that you saw in the course's trailer video. Mainly, this is animation. As a rule, expressions significantly simplify animation. For example, by using linking, mathematical formulas, conversions, and many other things that we will cover throughout the course. However, everything begins with the basics. Let's first talk about layer properties. Open the first composition of the lesson. We can move and rotate the submarine's layer as well as increase and decrease its size. We do this by using the position, rotation, and scale properties. Let's go deeper to figure out what these things mean. These are the layer's properties. They belong to the transform property group. We will see this group by clicking the triangle to the left of the layer's name. Besides these properties, there's also anchor point and opacity. And if we switch the layer into 3D mode, there will also be orientation. How are properties different from property groups? Property groups only contain properties or other groups. Contents, masks, effects, and transform are all groups. Each separate effect or mask is also a group. Let's look at the contents property group. Only shape layers have it. We'll demonstrate using a simple rectangle as an example. Select the rectangle instrument or press Q on the keyboard. Create it. The layer immediately expanded to the rectangle 1 group. This is one more group that belongs to the contents property group. Let's expand it. With this triangle, it's easy to understand what we're looking at. A property group or a property. We can see a few more groups in rectangle 1. Expand the stroke 1 group. Everything in the stroke group besides dash is a property. Properties have values. If there's a timer icon to the left of the property's name, then we can modify it with the help of keyframes, as well as by using expressions. If the property doesn't have this icon, as with composite and line cap, for example, then the value can only be selected once from the drop-down list. We're not interested in these properties because we can't modify them by using expressions. We're only interested in the properties that we can animate. Let's delete the rectangle and expand the submarine shape layer's rotation property. To do this, select the layer and press the R key. We'll only see the necessary property and nothing else. We will always show you the quickest tricks to speed up routine tasks. All properties that we can animate using keyframes can also be animated with expressions. Expressions are just an alternative method to give value to a property. To create an expression for a property, we need to click on the timer while holding down the Alt key. Then we see the expressions interface under the property. The values turn red, and the expressions editor opens in the timeline. If your editor looks differently from mine, it means that you have an older version of After Effects. Starting with version 16.1, the editor was updated with new functionality to simplify writing expressions. You can check your version by opening Help in the menu and clicking About After Effects. You'll see the version here. If it's older than 16.1, you won't be able to use the updated expressions editor. You can update After Effects, but this isn't completely necessary. The expressions that we're going to learn will work in older versions as well. You just won't have access to some features that make work more convenient, like highlighting syntax, for example. But these features are optional and you'll still be able to complete the tasks without them. Let's have a close look at the expressions interface. If the property's value is red, then it's given by expressions. Values given by expressions have higher priority than ones given by hand or with keyframes. Let us demonstrate this. Delete the code inside the expressions editor and type 100. Even though we can still change the property value by hand, and it does seem to change, as soon as we end the change it becomes 100 again, and the image in the viewport doesn't get updated. This is the easiest way to give value to a property by using expressions, just typing the necessary number in the expressions editor. What's more is that this value is given in a way that makes it impossible to change while the expression is turned on. This is very convenient, especially when we don't want to block the entire layer with the lock switch, but only want to fixate the values of some properties. However, the value that we modified did not go anywhere. If we click on this equal sign icon in the expressions interface, then we will see that rotation immediately takes the value that we gave it by hand while the expression was working. Using this switch, we can turn the expression off without deleting it. Let's animate rotation. Make it so that its value changes from 0 to 90. Now click the equal sign one more time. Regardless of the fact that the property is animated, its value is still 100. We can delete the expression by deleting all of the text in the expressions editor or by clicking the timer while holding down Alt one more time. For now, let's bring our expression back. Now let's see what the second switch in the expressions interface does. It turns on the value or speed graph after applying expressions. Let's turn it on and open the graph editor. Make sure that you turned on the value graph, not the speed graph. Right-click on the timeline and select Edit Value Graph. You see two lines. One corresponds to the original value given by using keyframes, which changes from 0 to 90. And the second is given by using expressions, and looks like a straight line at the 100 mark. We will use this function often in the future, but for now let's turn off the expressions graph and leave the graph editor. The next element in the expressions interface is the Pick Whip tool for expressions. This is the instrument for linking, and we will use it regularly. It works similarly to the Pick Whip tool for layers. We can use it for linking properties of any layer and in the Effects panel. Open the rotation of the second submarine. Select the layer and press R. Now let's use Pick Whip to link the rotation of the first submarine to the rotation of the second one. Now change the value of the first submarine's rotation. Great. Now the first submarine rotates with the same value as the second one, but they both rotate around their own centers. We can't get this kind of rotation with regular parenting, since the parented layer will rotate around the anchor point of the parent layer. This is the simplest way to link one property to another. This way we can also link the opacity properties, something we can't do with regular parenting of layers. The last element in the expressions interface is the catalog of expressions that are available for us to use. We will need it later. For now, delete the expression and then the second submarine. Next, we will discuss the values of properties in more detail. More often than not, the values of regular properties are just regular numbers, like with opacity and rotation. The value of opacity can change from 0 to 100, and with rotation, it's basically unlimited in any direction. If we give them values by using numbers inside expressions, then we won't be able to change them. However, we often need an animation that is graded by both keyframes and expressions at the same time. To do this, we need to somehow get the current, original value of the property in the expression. That is why every property has a special variable, value, that contains the original value. A variable is a container with a name that contains certain information. It can contain an egg, a chicken, a piano, a whale, or the whole planet, and even all of the above put together. We only see the name of the container, and if this name is selected carefully, it is immediately clear what this container variable contains. For example, the name value tells us that there is a value inside this container. What value? The value of the current property, the property for which we're writing an expression. Value is a reserved variable. This means that we can't modify what this variable contains. It is given by After Effects itself, and we can only refer to it and use it. If we type a value in the rotation expression, we won't see any changes. Now we can change the value as we want and animate the property using keyframes, but expressions won't influence the animation. The value property always contains the value of the property at the current moment in time, or the composition time that corresponds to the position of this slider. However, this doesn't mean that the expression doesn't work. It just gives the property the exact value that is given by the keyframe animation. However, everything will change if we multiply the value by 2. Now the value is equal to 2 times what is given by the animation. Let's turn on the value graph. You can clearly see that the expressions graph is twice as big as the keyframe graph. If we change 2 to 3, it will be 3 times higher. Now a little bit more magic. Duplicate the submarine layer and move it slightly to the side. Now let's add 50 to the expression. We can see that the whole graph immediately shifted by 50 units up, and the submarine is turned by exactly 50 degrees more than the second one. And the thing is that our keyframe animation is exactly the same, but because of different expressions, it looks completely different. Why does this happen? The thing is that value is still just a number, only inside of a container. Since it is a number, we can perform any mathematical operations on it, meaning addition, subtraction, multiplication, and division. They're all available for us for calculating values. Besides reserved variables, we will also create our own, but in the next lesson, not this one. For now, let's look at one more reserved variable, time. Time is a variable that stores the composition's current time, which corresponds to the position of this slider. The number contained in this variable increases with constant speed from the composition's starting time, which is usually 0, to the end of the composition. Let's check this. Open the composition 02 time. We need a text layer. To create it, press Ctrl+T on the keyboard and click anywhere in the viewport window. We won't type anything into the actual text. Let's open the source text property. For this, we need to select the layer and press Ctrl+F on the keyboard, which will immediately make the search field active. Start typing source, and the necessary property will open. Perfect. Let's open the expressions interface by holding down Alt and clicking the timer. In the expression field, delete all text and type time. Make sure that your text has a different color from the background, otherwise you won't see anything. Since the slider is in the beginning of the composition and the composition's time starts from 0, the text will also show us 0. If we press space to start the animation, we will see that the number constantly increases. It will be equal to 1 at 1 second, 2 at 2 seconds, and so on. Time is a variable that contains the composition's current time. Just like with value, we can perform any mathematical operations on it. Let's multiply time by 2. The number started increasing twice as fast. We will create many different animations with the help of this variable. As an example, let's create a realistic animation of a clock by using time. We have applied expressions to the necessary properties beforehand. To not have to look for them and to expand all the properties that have expressions added to them, select the clock layer and press the E key twice. We need the 3 top properties: sec, the second hand, min, which is the minute hand, and hours, or the hour hand. Just so there's nothing that's unnecessary on our screen, let's hide the properties that we don't need by holding down Alt plus Shift and clicking Transform Repeater that contains these properties. Type time in the minute hand's expression. The hand starts its movement, but as we can see, quite slowly. To speed up the animation, let's multiply time by 100. Thanks to this, the hand will turn 100 degrees every second. If we need to change the starting position of the hand, we can add or subtract the necessary value. For example, plus 60. This way we shift the hand by 60 degrees depending on the hour hand, or each 10th minute. A little later, we will animate the second and hour hands so that they are dependent on the speed of the minute hand. For now, this is enough to see how to use this variable. In the exercises folder, do the tasks in the composition that are in the time folder. You'll find a few more interesting uses of this variable there. Now the time has come to get acquainted with functions. If variables contain values inside of them, then functions carry out actions. Let's take a real-world example. If a variable is a container and contains something, then a function is a complete instrument, or even a machine. For example, a washing machine. It receives something, dirty clothes, detergent, wash settings, and then returns clean clothes to us. We don't care how it does this. The most important thing for us is that it receives dirty clothes and returns clean clothes. This is an example of a function that receives some data and returns altered data. In programming, it will look like this. We type the name of the function, washer. After the name, we type parentheses. This is the same as the start button. In programming, this is known as calling a function. In parentheses, we type arguments. Dirty clothes, washing powder, temperature, and washing time. In other words, we send it the variables that contain dirty clothes, detergent, temperature, and wash time. And the result of the work of this function will be clean clothes. Pay attention to how I named the variables. The name of the variable begins with a lowercase letter. If the variable contains 2 or more words, then each following word is written without a space and starts with a capital letter. This is called the camel case style. However, functions do not always receive data. Let's take a lighter as an example. We just need to press a button and we get fire. In this case, we didn't send any data, just pressed a button. In programming, it will look like this. We type the name of the function, lighter, then after parentheses, press the start button or call the function, and we don't need to write anything in the parentheses. It doesn't need any special information. It returns fire. These were abstract examples, but believe me, in games, a lighter and a washing machine will be created approximately like this. In our case, let's refer to a real function from After Effects. For this, let's go back to our text layer and type random with parentheses next to it, in the source text properties expression. Random is the name of the function. Its purpose is to return a new random number each frame. To make it do something, we need to type parentheses after its name, and put 2 numbers inside, the range in which our random number should be. Let's type 0 and 10, and start the animation. New numbers appear in each frame, and they are all in this range. This way our random function receives 2 numbers that are the endpoints of the range, and these are the function's arguments. Then the function returns a random number from this range in each frame. In After Effects, there are very many different functions that we will use in future lessons. For now, the most important thing for you is to understand that functions perform certain actions. Let's open the minute hand expression in the clock layer. Let's type random parentheses 0360 into it. Start the animation. As we can see, the hand jumps chaotically in the range of these numbers. We will use random values quite often. This is a whole block of functions that we will study in detail in the lesson after next. Let's go back to values. Open the third composition. Not all properties have numeric values. For example, this text layer has a text value, or to put it more correctly, the line data type. We will talk about it in more detail in the next lesson. Properties like position and scale have a value in the form of 2 or 3 numbers, each of which usually controls its own axis. When there is more than one number, the value is represented as an array of numbers. Let's look at what an array is in more detail. Arrays are structures into which we can put a few values. Values in an array are called the array's elements. Each element of an array has its own order number or index. The numeration of indexes in an array starts with 0, meaning the first element of an array has the index 0, the second index 1, and so on. If you've never dealt with programming, you'll need to get used to this, because in programming this is common. The values for position, anchor point, and scale are represented by arrays with 2 elements for the 2D layer and 3 elements for the 3D layer. All the elements in these arrays are numbers. The first element is responsible for the x-axis, the second for the y-axis, and the third for the z. Let's turn off the 3D mode for now. To get any value from the array, we need to use square brackets, inside of which we put the index. To clearly see this, let's go back to our text layer. Expand the text layer and link source text to the position property using the pickwhip tool. The expression of the linking appeared in front of us. It represents the position property's address. We will look at it in more detail a bit later. But for now, let's pay attention to the end of the line, to these square brackets. There's a 0 inside of them. This is the index of the array's first element. By using it, we refer to the first element of the position values array, and get the x value. To get the y value, we need to replace 0 with 1. To see the entire value, the whole array, we need to remove the square brackets in the end, type a period, and type value. If the value variable contains the value of the property that contains the expression, we can get the value of the other property by using this value, typed after a period. Now we see that we have two numbers that correspond to the value of position. Now let's turn on the 3D mode on the layer. Now we have three numbers separated by commas that correspond to position's value. Now let's try to get just the position's z value. To do this, add square brackets after the long expression in source text. To get the array's third element, type 2 in the square brackets. Change the value to z. Everything works. Delete the text layer and turn off the 3D mode. Let's figure out how to give fixed values to properties with an array of 2 or more values, like we did with rotation by typing 100. It's simple. Let's type parentheses in the scale properties expressions editor and type 200, 200. The value was applied immediately. Now let's try to change the layer's scale by hand. We can't do it. It's fixed by the expression. However, once again I repeat that this doesn't mean that the changes were not saved. If we turn off the expression, we will see that the layer changes. With values in the form of arrays, the value variable works the same way as it does with numbers. If we type value, then when animating the scale parameter, the expression will not do anything. Now here's something cool. Can we fix only one axis? Yes. Let's put value in square brackets and after it type another set of square brackets and type 0 inside. Then after a comma type 200. Turn off the linking of values and try to change scale's x value. It changes. Now the y value. It stays the same. Let's figure out what's going on. Since the scale value is represented by two numbers, we need to give the expression an array out of two numbers. The first value is the x value from the array. This means that we're getting it from the property without changing it. But the second value we indicate using a number, and that means that it cannot be changed. Let's copy this expression and paste it into position. To do this, right-click the scale property and select Copy Expression Only. Expand position by clicking the layer and pressing P on the keyboard. Select the property and press Ctrl+V to paste the expression. You can see that now we can freely move the layer along the x-axis, but can't move it along the y-axis. This can be very useful, for example, when we need to create shape controllers. Arrays can be multiplied and divided by a number, but to add or subtract from them, we also need arrays. To move the layer by 300 pixels down, we can add a new array, 0, 300, to the existing one. We can also perform any mathematical operations inside the array. For example, subtract 100 from the x-axis. We're virtually not limited in any way here. We can also use functions inside arrays. For example, if we type random 0, 300 instead of 300, then we will see that our layer will start to shift in the y position. There are lots of applications, and we will look at many similar examples throughout the course. Let's go back to linking with expressions in the fourth composition. This is one of the basic tricks that significantly simplifies work with animation. It's very important to familiarize ourselves with them, because by using them, we can create these cool animations. How does regular parenting work? We can move each submarine's layer as we please. However, very often we need to synchronize similar objects so that they move at the same time. We need this to speed up our work, so we don't have to animate each layer separately. To do this, we can parent layers one with another using the parent column. If you can't see it, right-click on the column name in the timeline panel and select Parent from the list. Parent the first submarine to the second one. Now, whatever changes we make to the parent layer, the parented layer will fully repeat them. Actually, this is the main limitation. First of all transformations will occur around the parent layer's anchor point. Also, if we need to link only the position and leave rotation independent, we can't use regular parenting. Also, with regular parenting, opacity remains independent, but sometimes we need to link it as well. To do this, we need an instrument that is more flexible than regular parenting. This instrument is linking with the help of expressions. Let's cancel the parenting of layers by choosing None in the dropdown. Now let's link the scale of the first submarine to the scale of the second one. Now change the second submarine's scale. Notice that the first submarine's scale fully copies the value of the second one. When we parent layers, the parented layer depends on the parent layer, but it can still change by itself. With direct linking of properties, the values fully copy one another. This will be especially noticeable if we link the position of our layers. In the scale properties expression, divide the whole expression by 2, so that the scale of the layers differs. Now select both layers and press the P key. Link the first layer's position to the second one. The first layer immediately moves to the second one. Now we can't change its position. It will always follow the second one. If we just parented layers one to another, it would work differently. By the way, to keep the ability to move the first submarine, but also keep it parented to the second one, we need to add value to the end of the expression. Now as you can see, we can edit the first submarine's position. This way, linking with the help of expressions works completely differently than the parenting of layers. We can also link the path property. Let's find the submarine body's path. There are many internal shapes in the layers, so for convenience we've already named the necessary shape's base form. Let's find it by using search. Select 2 layers. Press Ctrl+F and type base form into the search field. Let's link one path to the other. Now by changing the shape of one submarine, we change the second one in exactly the same way. Everything works. We can duplicate the first submarine a few times. Each new submarine will also change the same way as the second one, regardless of where we place it. This is a flexible approach that expands the possibilities of regular parenting of layers. It is very important to understand how this works. Now we need to finally understand what we get in the expression when we link properties to one another. Look at the positions expression. It is quite long. This is the link or address where the position property to which we are linking is. This is like a link in a book. The book's name, section, chapter, subchapter, and so on. The expression starts with this comp, which literally means this composition. Layer shows us in which layer it is, indicated in parentheses. Transform is the layer's property group, and the actual position property that is inside the transform group. All these nesting levels are separated by periods, and the whole expression represents the address of the position property. To understand what we get from the periods, let's look at this address from a different angle. Look at our expression in more detail. It starts with this comp. This comp is the variable that contains the current open compositions object. Objects are special types of data. Compositions, layers, and many other things in After Effects are all objects. An object is like an array, only in arrays we got values through the index, the number in square brackets. But in objects, the value is inside containers with names. Sounds familiar, doesn't it? Yes, they are just like variables, but not independent. They belong to a structure of a higher order. These variables are called object attributes. Each attribute contains a value of some type: line, number, array, or even another object. To get access to an object's attribute, we will use the access operator, period. How does this work? We have the compositions object, this comp, and it has many different attributes: width, the composition's width, height, and frame duration, the duration of one frame. You can see all of the composition's attributes in the catalog of expressions in the comp category. Besides attributes, objects also have methods. If an attribute is a variable, a container to store data, then a method is like a function, an instrument for performing certain actions. Visually, they differ by parentheses that can contain something after the word. We have a method directly in our expression. After this comp, we have the access operator, period, and then the layer method, or function, inside the method's parentheses. There's a line with the layer's name. The layer composition method's task is to return the layer. Inside parentheses, we put the layer's name in quotes, and the method finds this layer in the current composition and returns it. If a layer with this name does not exist in the composition, we will get an error. Then there's transform. The transform property group is an attribute of the layer's property. You can find other layer attributes and methods in the catalog of expressions, in the layer category. The position property is the transform object's attribute. This means that the address represents a hierarchy of objects, from top to bottom. Using these addresses, separated by periods, we can get data from different kinds of objects. When you get enough experience, you won't even need the pickwhip tool for linking. You will be able to type the address to the necessary properties by yourself through memory. So we figured out how to properly do linking and what possibilities it gives us. There are many nuances in the work of properties and their values, but with practice you'll get the hang of it. Now we can easily solve the task with the hour and second hands in the composition 0 to time. Return the time expression multiplied by 100 to the minute hand. It is easy to create realistic animation for the other hands. First, it's enough to link the hour hand's rotation property to the minute hand's rotation, and divide the expression by 12. Why by 12? The hour hand makes a full turn in 12 hours, meaning that it moves 12 times slower than the minute hand. The second hand moves 60 times faster than the minute hand. First, link its rotation to the minute hand's rotation, and then multiply by 60. In similar tasks, we use multiplication to speed up the animation, and division to slow it down. Now, by changing the animation of the minute hand, we will also change the animation of the other two hands. Delete the animation from the minute hand and animate it using keyframes. It doesn't matter if we use easing or reverse movement. The hour and second hands are linked to the minute hand and will fully repeat the animation according to what's indicated by expressions. Try to go through the small linking tasks in the linking folder on your own. Now here's a small task for you. Knowing how the animation of hands and linking works, create a world clock in the homework composition that will be linked to your current time. When the local time is changed, other clocks should automatically adjust to it. Also, add the possibility to adjust the time by hand using the value variable. Good luck!